Objective 2, Quadratic Functions, Part 1. We'll have several videos for this section. It's a little bit longer than the earlier objectives. First of all, standard form for a parabola, f of x equals a, parentheses, x minus h squared plus k. The vertex is hk. That means we can go over h up k. I notice the minus in front of the h. That corresponds to a right transformation by h. Add k, that moves the function up. And if a is greater than 0, this will be a concave up parabola. If a was less than 0, then it would just go downward. For example, f of x equals 2 times x minus 3 squared plus 5. The vertex is at 3, 5. We extract those two numbers. A is 2, greater than 0, so it's concave up. And so a very quick sketch, over 3 up 5. There's the vertex, and it opens upward. We're interested in this section of basically extracting information from an equation. We don't need a refined graph necessarily. But the first set of problems, we're actually going to figure out something about a parabola. Then we're going to plot a few points to verify this, this concave up or concave down property. So for instance, let's suppose we have f of x equals, well, let's take 2 times x minus 3 squared plus 5. And first of all, the vertex, you can say v parentheses 3, 5, just like we did over here. And if we want to draw a graph, we can make an xy chart, or xf of x, whatever your pleasure is. We're going to put the vertex in the middle, and then we're going to go up 1 and down 1. And then we can substitute 2. F of 2 is 2 times 2 minus 3 squared plus 5, which is 2 times negative 1 squared plus 5. And that's 2 times 1 plus 5, which is 7. So we put a 7 here. And then we can find f of 4. 2 times 4 minus 3 squared plus 5. And 4 minus 3 is 1. 1 squared. 2 times 1. Guess what? We get 7. We should expect that. Parabolas have symmetry about the vertex. You can see how we have symmetry about x equals 3. X equals 3 makes this 0, and whether you go right or left, it just becomes positive or negative. Now, as far as drawing a rough sketch of this, all we want you to do in the homework is just go over 3 up 5. There is graph paper provided on your homework packet. And then we also have 4 and 2. I guess this isn't drawn to scale. Let me draw a bigger picture here to scale. So we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 2, 4, 2, 4, 6. And we can 2, 7, over 2 up 7. And 3, 5, we go over 3 up 5. And then 4, 7, we go over to 4 and back up to 7. It looks like a V, but these parabolas don't have any sharp points. They are smooth. Okay. And that's all we really expect for this set of problems. So there's some very simple concepts here. You're seeing the numerical reason for symmetry about the vertex 3, 5. You can plug 3 in if you wished. I didn't bother, but 3 minus 3 is 0. 0 squared 0. 2 times 0 is 0 plus 5. That gives you the 5. So there's nothing like very simple numerical understanding of what's going on with this parabolic function. And here's a second type of problem. going to look at. Let's suppose we have a parabola through 0, 2, 1, 4, and 2, 8. You can sketch this parabola if you want a rough idea of what's going on. 0, 2 could be right here. 1, 4 would be up twice as high. And 2, 8 over 2 up 8 is even higher. So this is kind of just part of the parabola. Somewhere along the line it turns around and comes back up. And the question is, the general form of the parabola equation is ax squared plus bx plus c. We want to use these 3 points to find these parameters a, b, and c. You could do the ax minus h squared plus k, but they're nonlinear equations and a little bit more obstinate to work with. In this case, each of these points will generate a linear equation. It makes it easier to deal with. So, and besides, this is a good review of how to solve 3 equations, 3 unknowns. Consider the first point, 0, 2. That means y is 2, and we get a times 0 squared plus b times 0 plus c. We're fortunate that these 2 terms zero out. We get 2 equals c. Now, second of all, consider this point, 1, 4. If you substitute 4 for y, we get a times 1 squared plus b times 1 plus c. You can actually put 2 in right here as long as we have that. And subtract 2, these 1's go away. We really have a plus b equals 2. And then consider this point here, 2, 8. We can plug 8 in for y. And a times 2 squared plus b times 2 plus c. We have 4a plus 2b. Well, 2 we can plug out, or c we can plug 2 in. I forgot about that. Equals 6. Subtract 2 from both sides. And you could divide 2 out, shrink this equation down to 2a plus b equals 3. Now ultimately we have 2 equations, 2 unknowns we have to solve because we already have c solved for. So we have, let's copy up here, a plus b equals 2, and then 2a plus b equals 3. And you can subtract, for instance, a minus 2a is negative a equals negative 1. The b's cancel. And we get a equals 1. Now we're 2/3 of the way there. We can back substitute. You can take this 1, put it in right here, for instance, 1 plus b equals 2, b equals 1. And so our function, 1, 1, 2, our final answer, I guess, is f of x is 1x squared plus 1x plus 2. We found the parabola that fits these 3 data points. So in the world of data analysis, we may have a lot more data points. And of course, we would do some sort of regression. You could use technology to do a quadratic regression. That's certainly possible. But here we're interested more in the pure coordinate geometry. Regression's a different matter. So here's another example, a little more complicated. Let's suppose we have the points 1, 4, 2, 8, and 3, 14. We're not lucky enough to have an x-coordinate of 0. And we want to find f of x equals ax squared plus bx plus c. Well, let's plug in some points. We can plug in 1, 4, and we get 4 is a times 1 squared plus b times 1 plus c. And of course, can't solve for c because the a and the b term don't go away. But you can simplify this to a plus b plus c equals 4. And you can call this equation 1 if you wish. We also can plug this point in, 8, 2. This was from the point 1, 4. 2, 8. Okay, we can plug in 8 for f. A times 2 squared plus b times 2 plus c. Well, you can square that. 2, I get 4a plus 2b plus c equals 8. And you can call this equation 2. Now we can come up here, we can use the point 3, 14. Plug 14 in for f. Let's erase this part of the solution. 14 equals a times 3 squared. Plus b times 3 plus c, and that gives us 9a plus 3b plus c equals 14. Call that equation 3. Now we have 3 equations, 3 unknowns, and we don't have the fortunate circumstance of having one of the equations giving us a variable. So, well, we'll provide a solution to this. The first strategy is we want to eliminate a variable twice between 2 pairs of equations and reduce this to a 2 by 2. And so we can take, for instance, equation 1 and equation 2, and you can eliminate c by subtracting. So our overall strategy is we're going to subtract these 2 equations, eliminate c, subtract these 2 equations, eliminate c, and that will give us 2 AB equations. And then we can just solve the AB system. So we can take, for instance, equation 1, a plus b plus c equals 4. In equation 2, which is 4a plus 2b plus c equals 8, subtract. Okay, I didn't leave room for my subtraction symbol. A minus 4a is negative 3a. B minus 2b is minus b. C's cancel. Negative 4. And if we want, you can zap this with a negative 1 and it gives us 3a plus b equals 4 if you want to stick with the positive realm. We'll call that equation 4. And then we take equation 1 and 3, for instance. A plus B plus C equals 4. And equation 3, 9A plus 3B plus C equals 14. Subtract those two equations, we get negative 8A minus 2B equals negative 10. And we can divide by 2, divide by negative 2 for that matter. We get 4A plus B equals 5. Call that equation 5. So now we have two equations, two unknowns. Very easy to eliminate B. We could eliminate A if we wanted. You'd multiply that by negative 4 and that by 3 and then add it together, or 4 and negative 3, but no need to do that. So we have 3A plus B equals 4. 4A plus B equals 5. You can label these. Good idea to label what you're doing. And if you subtract, negative A equals negative 1. A equals 1. And you can this is called back substitution. You can take this A, plug it in either equation, doesn't really matter. You can plug it in equation 4, and we get 3 times 1 plus B equals 4. B equals 1. That's a shabby B. And then we can substitute into equation 1, for instance, to solve for C. A plus B plus C equals 4. Substitute 1 and 1. 1 plus C equals 4. C equals 2. Okay. This may look familiar. It's the same parabola, just 3 different sets of data points. F of x equals 1x squared plus 1x plus 2. It's the same parabola. It just took a little bit more work to get that. So that concludes this video. We'll be back for more.